Your nose is amazing, and I'm not just saying that. It plays a huge role in how we experience taste because it is so sensitive to the volatile odor molecules emitted by what we eat and drink. If food scientists had their druthers, they'd have human sniffers smelling for indicators of food quality at each stage of production. Imagine a platoon of people keeping their noses on, say, a winery's grapes from vine to bottle, making sure we're getting the best product possible. Of course, there are problems with that scenario.
People are noisy instruments. They get tired, they get distracted. The other problem is that people want to go home occasionally.
This is where analytical machines have a leg up on people, but there's still no noses. Scientists are closing that gap though, and that's what led us to Gavin Sachs and Jessica Rafson at Cornell University, who are working on a speedier approach to volatile analysis. They're using mass spectrometry, which is a very useful tool for measuring volatile odor molecules. As of now, the bar for this type of mass spec work is set by gas chromatography mass spectrometry, or GCMS, but it's time consuming. Jessica tells us you can run only one sample at a time, and it takes 15 to 60 minutes to extract and collect the sample before you start the analysis.
And then you have to run it through the GC column, which takes another 30 minutes or so, and then it's sent over to the mass spec. So you're limited to one sample in, an hour's time or something like that.
The Cornell team is developing a different type of mass spec technique. Here's how it works. They start by depositing liquid samples on a thin layer chromatography plate. The volatiles quickly escape the sample, but the team catches them using a silicone mesh. Yeah, they just place it right over their samples there. They call this step solid phase mesh enhanced sorption from Headspace, or SPMesh.
Silicone can swell, which is like a sponge, to absorb a broad range of volatiles. It's not a terribly expensive material. You can buy silicone or its monomeric precursors very easily.
After a couple minutes of letting that silicone sponge up odorants, they take it over to a direct analysis in real-time mass spec system, or DART-MS. The DART part of that desorbs the volatiles from the mesh so they can then flow into the mass spec for analysis.
So the DART is basically a stream of very hot metastable helium that ionizes your sample. I think we were using 300 degrees Celsius.
The whole process, sample collection, desorption, and analysis, takes about 15 minutes.
It is pretty straightforward, which was fantastic.
So it's faster than GCMS, and they're able to run multiple samples at once. Of course, there are trade-offs. So both GCMS and SPMesh DART-MS will give you mass spectra, obviously. But the GC column in GCMS gives you additional information about the compounds in your sample, things like polarity and boiling point. SPMesh DART-MS does not give you that info, meaning you're missing valuable data that would help identify mystery molecules in your sample.
If you have a sample where you know nothing about what's in it, combining SPMesh with DART-MS or some other mass spec approach is not an appropriate way of figuring out what's in the sample.
But the good news is that most, say, winemakers already know what they're looking for when they're evaluating their products. And Gavin's team is going to field test their new approach soon.
This summer, one of the other students in the lab is going out to the West Coast to work with E&J Gallo Winery. And the goal is to see if we can drop in SPMesh DART-MS as a replacement or something complementary to what they already are doing.
The team also has some other interesting ideas for the technique, such as sticking a mesh inside someone's mouth to look at the volatiles in there.
What we think we can do with SPMesh is actually make a... Did you see that?
Yeah.
So make a tongue print and do a SPMesh extraction off of the tongue print and see where volatiles are distributed in the mouth.
Gavin says that figuring out where volatiles hang out on your tongue could help us better understand off-tastes and aftertastes, which could in turn help scientists figure out how to better avoid those. So cheers to a tastier future. If you're watching this on YouTube, please click that subscribe button now. And if you're watching on our website, click that videos button up there to check out even more great chemistry news videos.